Hello. This time we take a look at objects from the Java point of view. I have IntelliJ open here. You can see some packages from other examples. But let's first create a new package for this example. Packages are a good way to organize and structure your code. Remember from the previous video about the concepts of objects. I have defined an object template, and I could create instances of this template, for example a rectangle. In Java, a class is a template for an object. If we use the rectangle example, I can create a new class file like this. I need to provide a name for the class, and I will call it rectangle. Now I get a Java file here with some initial code in it. At the top I have the package name. You'll notice it matches the package hierarchy in my Project Explorer window. Then the word public. This is an access modifier. And public means that this class can be used by other classes, as we will see a bit later. Here the word class, to say this is a class, obviously. We can define other types like enum or interface, but I will not cover that here. And then the name rectangle. Let me just find the template for the rectangle from the previous video again. We can see it has properties. I will add those. The methods will be covered in another video. Now, the word property is a bit general. In Java here, we usually call them attributes, instance variables, or field variables. I personally call them field variables and will probably do that in most of my videos. We define a field variable like this. First, the access modifier. This time I use private. This means that the field variable will not be accessible by other classes. This is part of the topic of encapsulation, which I will not cover here. By default, your field variables should be private, unless you have a very good reason not to. Field variables, as the name suggests, are variables. And you already know that when you declare a variable, you first declare its type. It's the same here. This field is of type int, and then the name, width. It could have been double or float if I wanted to allow decimal numbers. My object template, which is this class here, now has a property, a piece of information about it. That's my field variable here. Similarly, I can define a field variable for the length. In the video about conceptual objects, I also have the area as a property. I won't do that here, because the area can be calculated based on already existing data, width and length. And lastly, I have the color property. To add that, I will define another field variable, still private, but this time the type is string, and the name of the field, color. So far, so good. But what can I do with it now? Let's try to use the rectangle by creating new instances of it. To do this, I create another class, which is more like the usual class you make in your exercises. It will contain a main method, so I can actually run my program. Let me just create the file here, call it rectangle example. I will just move the two files side by side here, and then add a main method. There. Now, how do I get a rectangle? I need to declare a variable of type rectangle like this. And here we see the difference between primitives and objects. For primitives, I can assign a value directly. For objects, I need to create a new instance. Remember, the class we just created, that is the template. I can then create instances based on that template. I do that with the new keyword, and then a call to the rectangle constructor. All object types have one or more constructors. They are always called the same as the object type. The parentheses are used to provide data to the object if needed. Currently I cannot do that. We will get to that in a moment. Now I have a new instance of a rectangle. Let me just create another one. And then what? What can I do with it? Well, currently not much. But let's try to print them out to the console. I run the program. And we get some kind of general representation of the object. Notice the representation is different for each instance. But this is fairly useless, so without going too much into details about methods, let me just add one, which can print out the object in a nicer way. You have occasionally encountered methods, and I will formally introduce them later in another video. For now, I create a display method which just prints out the field variables in some kind of formatted way here. I won't dwell too much on this. And let's run the program again, and we see two rectangles printed out with their values for their field variables. You'll probably notice that the values are just the default of their respective types. That's because I have declared the field variables, but never assigned values to them. Notice the gray color for the fields indicating that they are not used. So the next step is, how do we go about creating a rectangle with actual values? What I would like to do is, upon creation of the rectangle up here, I would like to also provide the relevant values. Say a width of 5, a length of 8, and blue for the color. You'll now see the compiler complain, the red squiggly underline here. I have attempted to give values to my rectangle, but my rectangle does not really know how to deal with this. So I need a new constructor which can accept these values. Remember, the constructor is used when I want to create a new instance of an object. I go over to the rectangle class and I need to create a constructor. It is okay to have multiple constructors if your object can be created in different ways. I just need one. I will add a constructor here. It is public, so it can be used from other classes. And the name is always the same as the class, in this case rectangle. I need to define parameters, meaning what data this constructor can accept. I define them like variables here between the parentheses. A constructor can declare between 0 and many parameters. Currently my constructor declares 0, and I need to change that. The first parameter is the width. It is of type int. Then a comma to separate the parameters. Then the next, which is the length of type int. And finally the color of type string. Let me just reformat this so we can see it all. If I now look at my main method, you'll see the compiler no longer complains about the first rectangle. But the second rectangle is now the problem, because I no longer have a constructor which takes no arguments. So let me just input some values, 5, 5 and burnt orange. Notice the arguments here are comma separated as well. When we declare the variables for the constructor, we call them parameters. When we provide variables when calling the constructor, we call them arguments. It's a minor detail, but there is a difference. Okay, so I am creating two instances of the rectangle class, and now I am passing in arguments, the data here, to the instance upon creation. Still though, if I run the program again, I don't see the correct values. And that's because the rectangle receives the values through the constructor, but I have not specified what to actually do with them. Notice these two are gray, meaning they are not used. I get the values here as constructor parameters, and I want the values to be assigned to the field variables. This is just a normal variable assignment, fairly straightforward. But when I want to reference field variables, I can use the this keyword, dot, the variable name. Notice the color coding of this variable versus the constructor parameter. The color gives a hint that even though I have two variables with the same name, I am referencing the field variable here. And then an assignment to the constructor parameter here. Now my constructor receives a value for the width, and that value is stored in the field variable called width. I repeat the process for length and color. And now when running the program again, I actually get the print I was hoping for. So now you have seen an example of how to define a new object type, the rectangle here, by creating a class for it. The class can have field variables, which is the data for this object type. And I use the constructor to create new instances and define what data is required when creating such an instance. This will be all for this introduction.